This lesson is on section 4.4, using congruent triangles. In the last two lessons, we have shown the 4 different ways that exist in order to prove that two triangles are congruent. Side, 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 angle, side, angle, and angle, angle, side. You need 3 pieces of each triangle to be congruent in order to show that the triangles are congruent. But what about the other 3 corresponding parts in the triangles? The 3 parts that you didn't use in order to prove that the triangles are congruent. Do you know anything about those? And the answer to that question is yes. Once you use side, 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 angle, angle, or angle, angle, side to prove that 2 triangles are congruent, then the other 3 corresponding parts that you didn't use are also congruent. They are congruent because of a theorem called corresponding parts of congruent triangles are congruent. We abbreviate it CPCTC. Okay? CPCTC means that after you prove 2 triangles are congruent, then you can say the rest of the corresponding parts are congruent. An example of wanting to use CPCTC might come like this. In this example, they want to show that segment AB and segment DE are congruent. They're not reflexive sides, and it isn't given to us. So how can we show that AB and DE are congruent if we don't have any reasons? And the answer is, if we can show that the triangles themselves are congruent, then AB and DE would have to be congruent using CPCTC. So in order to use CPCTC, the order that you have to use things is, first you have to find your 3 congruent parts of your triangles, the parts you know, using things like given statements, reflexive sides, vertical angles, parallel lines, and bisectors. After you show your 3 congruent parts, then you say that your triangles are congruent using one of your 4 postulates or theorems. After you use one of those 4, then you can use the theorem CPCTC to show that your other parts are congruent. An example right here. Okay, we are given that AE and BD bisect each other. So that's a given piece of information. We will write that in. AE and BD bisect each other. Because they bisect, that gives us some congruent pieces. Okay, bisect means to cut in half. That means AE is cut into 2 equal parts, and that means BD is cut into 2 equal parts. So because we were given that we have bisectors, we have that AC is congruent to EC, and that BC is congruent to DC. And our reason for that would be the definition of bisect. Okay? There's 2 of our 3 congruent parts. Now we have to find our 3rd congruent piece, looking for these types of things. The one thing that we have in this picture is angles that form an X. So we have vertical angles. So our next step would be to say that angle ACB is congruent to ECD, and that's because of the vertical angle theorem. Now we have our 3 congruent parts, so we can say that our triangles are congruent, and I'm going to use the same order. Triangle ACB is congruent to triangle ECD, And the order of my pieces is two sides and their included angle. So it is side angle side as my reason. And now my ultimate goal was to prove that AB equals DE. And I can now say that because my triangles are congruent, then all of my extra parts are congruent using the theorem CP-CTC. That's how I know that AB and DE are congruent. I couldn't prove it before, but now once my triangles are congruent, then my other pieces are congruent. I could have used CP-CTC to show that angle A was congruent to angle E, or also that angle D was congruent to angle B. I could have used CP-CTC for that as well. That concludes this lesson on how and when to use CP-CTC. The homework, according to each class, is as follows.